Okay, what we're going to do now is that we're going to draw a pipe system, like what you see on the screen now. So this one I already sent to you yesterday, and also you can find this diagram in the Moodle. So this system works like this. So you have a few inlet. So you have inlet from the bottom. Okay, this is inlet, and the velocity is 0.4 meter per second. And then there's another inlet from bottom here, which is your UI. The velocity is 1.2 coming in. The temperature both is different. On the left, the temperature is 20 degrees C. On the bottom here is 40 degrees C. Okay, and on the top here, you see there's an opening there. So later on, we'll simulate this one. We'll put in as a pressure outlet. And the dimension is given as what you see on the screen, or you already print out in your hands-up. So we have a curve, a cylinder, and with the elbow, and the length of the elbow is 200 mm, both sides. So either horizontal or vertical. The curve feature, the height is 225, and the horizontal length is 137.5. Okay. So later we're going to use ANSYS to generate a model. Then we're going to use Fluent to simulate. So I assume you already opened up your ANSYS. So just beware that in the middle, maybe the software will crash somehow. Then you will need to start over again. Yeah. So before you start, in the Workbench here, you will see the toolbox on the left. So under toolbox, you have analysis system. So these are the model that you're going to use to simulate. So you have to know before you start using ANSYS, you have to know what you're trying to simulate. So there are lots of selection here. Yeah. And also we have another section called component system. So you can pull out a component from here to enhance your results. So in the later session, we will run two simulations simultaneously, and we will use one of the component here to do comparison results side by side simultaneously. Meaning we will run one simulation on pressure, on velocity, one on the new design, and then we compare. All right. So today we're going to use Fluent. So you go to your toolbox there and choose Fluent Flow. We're going to using Fluent Analysis System. So what you do is left click and drag to the project schematic window here, and you will see a and something here. So go ahead and label the system. The project they're going to do is called Elbow Projects. Maybe I call it Elbow A. So we're going to run two models today. But the first one I will just label as Elbow A, Elbow maybe -A, just to as a labeling. So by dragging the analysis system into a project schematic here, you are preparing the simulation to run the simulation. So from here, you will see question mark here, right? So I open up my PowerPoint slide here. So there are some meaning for the symbol here. Yeah. So if you see question mark, it means there's no data inside there. You need to input there or do something about it by left click or right click. And then this is the one that we want to see up to date. You want to see tick in all the window inside here. You want to see all the question mark to change to all the tick mark here. And in the middle of your simulation or setup, you will see one of the symbol will become refresh button like this. Refresh button means you need to tell the computer to do further instruction. Also right click and then choose the edit button and move forward. This is not what we want to see, where the system is interrupted. You will see a lightning strike. with two small square under it means the system is uninterrupted. Maybe you shut down the program immediately or without any warning. So you're interrupted or you press the stop button in analysis. Question mark with bold means attention needed. And input changes pending means you change, there's some changes you change during the setting. So you'll see the symbol, although you're already up to date, but if you go and click and change one of the parameter, then you'll see the symbol change to tick and the arrow. And then update required. This one is mandatory. If you do not do anything, the software do not allow you to move forward. Pending with the clock below the thunder sign here, you need to wait lah. Means the software is solving or analyzing the data. So these are the symbols that we need to understand what happened, what software trying to tell us. Now we need to create the geometry. So the flow of simulation is that we follow the number here, 1, 2, 3, 4 until 6 here. So we start with geometry. So start with the solid symbol here. So what you do is you left click, and then once you left click, you'll see the property window here. So at this moment, you won't do anything on the right hand side for the property schematic here unless you want to do parametric setting later on. So what you do, you go to here by selecting this one and then right click. Okay, right click. And then you will see the function come up. So my version, I have the space claim geometry. You need to buy this one if you don't have this one, but anyway, it's have the same function of design modeler. All right, so we're going to use the design modeler to create our geometry. However, you can import geometry from other CAD software, right? SolidWorks, or AutoCAD, or Inventor, and so on. Yeah. So yeah. So we're going to click New Modeler Geometry, left click, and wait for the program to pull out the design modeler. So you will see on the left-hand side corner, you will see a traffic light, and you open up the modeler like on the screen right now. So it depends on the speed of your computer. Sometimes this one will take a few seconds. All right. Okay. The next one is oh yeah, before we go for this, it's better we save our project first. So what you do, you minimize the modeler and then go and save your project first, because if not, it will hang somewhere. So go to File, Save the projects, and then go and find the name for the, I'll go and find the project file. So yeah, I will save somewhere here. And the project I will name as elbow project, elbow A, for example. Then I click save. So all your file now will save in the project file. So whatever you do, it will auto register in the log file that we covered last week. Yeah. So open up your design modeler. Yeah. Stop me if not able to follow or you are still behind somewhere. Yeah. So we're going to draw the, yeah. Anything? Go ahead.
No, sir. No, sir. Okay. Proceed, sir. Proceed.
Okay, good. Now, the first thing is that we need to be careful on the unit that we use. So on the screen that you see here, you go to the graphic window there, you'll see what unit is using by the computer now. So you see on my screen here, I see meter. So for engineering, most of the time when we do technical drawing, we seldom use meter. We will use mm. Now, as standard practice, we will use mm in all the engineering drawing. So what you do, you need to change the unit that you use throughout the simulation. So you go to the top or bottom here, you see File, Create, Concept, Tools, Unit. You go to Unit and choose Unit and choose So you'll see in the window graphic here, automatic change to mm. So make sure before you run anything, make sure the unit is correct. If not, later on the result will a bit weird and not logic. Yeah, and when it will become error or take more time when you do meshing also. Now we try to create body of our object here. We try to create this body first, then we extrude from both sides. So what we do is that we're going to create. So you go to File, Create. Beside the file, you go Create. So there are lots of shape that you can create here. So we are using the primitive shape, means already preset default shape or popular shape in the system. So we go to Create, move your mouse to primitive, and then we're going to use torus or donut shape. So left click. So you will see a donut shape come into your window here, and then the rest is just you go to the property window on the left hand side, which is a detail view here. We only need a quarter section of this shape, yeah, quarter section, because our shape only a quarter of the donut here. So what we need to do is that we will, if you go through the detail here, original is 0, 0, 0. So where is 0, 0, 0? You look at the diagram here, you see X, Y, Z axis. Yeah. So this object that you see on the screen here is on 0, 0, 0 position. And axis definition means you are using Z component in generating the object. So 0, 0, 1, 1 means you are activating Z axis here. So like my cursor is moving here, meaning your object is always, in this case, you're activating Z axis component. And then we need to change some parameter here. So we need to move our base definition a little bit to the back. So we go to Y and input -1. Okay. And then Z constant, and then angle. Angle by default, because you're creating a donut, so angle will always, you will go 360. We only need 90 degrees. So go here and change 90 degrees. Enter. So you will see in the graphic window here, the donut already become elbow or 90-degree elbow here. And then we need to change the inner radius here. By default, the software will remember the previous setting or previous setting that you set for other project. So in this one, 25 is a wrong answer. So you go to the diagram here. You see the diameter here is constant. So you see the diameter is 100 for throughout the pipe here. So what you do, you go to modeler, inner radius here, you need to change to 100, enter. Okay. And outer radius here, we change to 200, enter. 100 and 200, this one referring to diagram that you seeing here, yeah? Okay, so once you've done your setting, 100 and 200 at the bottom here, maybe you're using your handphone, so it might be a small number here, but I will guide you through, yeah? So make sure in the window on the left-hand side corner, because you're, oh, okay, my donut is missing. So what you do, you go to the top, there's a magnifying glass there. I will choose the zoom to fit, yeah? Or I can use my mouse middle to rotate, and then zoom to fit, rotate, okay? And yeah, that's it. When you okay, after you do setting, because you see in the graphic here is a gray line. Gray line is just a draft, so you need to generate it. So when you generate, you just go to the on the top there, you click generate. Yeah, so just click generate. You will see there's a elbow created in the middle here. So what you do is that I will zoom in. I'll go and click the magnifying glass, zoom to fit so that I can see my whole object. And to move your object, you can use your mouse. So middle wheel there, you just press down and you can rotate your object freely. Yeah? So this is how you use your mouse. So we already created the elbow. Now we need to, and also in the tree window here, tree outline here, if you expand the part here, you will see one solid there. Yeah. Okay. Now we're going to expand the two leg here or two edge here. So we're going to orientate our object. Then we're going to select the face here. So to select face, make sure on the top here, the selection here, you have a few selection. You have point selection, edge selection, face selection, and body selection. In this case, we want to select this face, so make sure this one was activated. Right, you can know the depth. Once it's selected, it's going down, and left click. You'll see green color come up. Okay. What we want to do with this surface is want to extrude. So once you selected the face, you go to the function that activated here. You'll see extrude, revolve, sweep, and skin. By looking at the symbol that you have on your computer, you know what is the effect when you press it. So we want to extrude this shape. Click extrude, and then the property window on the left is changing a little bit. So what you need to do is it will ask you, do you want to apply the geometry or not? All right. So of course you want to apply. So click apply. So you will see phase one here. And then there's my one is yellow highlighted here on the direction vector, because if you extrude, you need to tell the computer whether go up or go down. So you need to tell the direction vector. So go here, direction vector, and double click on the face here. Click apply. Okay, then you go to the direction is normal, correct, and then the depth is here. The depth we need to change a little bit according to the drawing. If you see the drawing, the depth is 200 length here, so we need to key in 200 here. Let me check if I key in the correct one. Yeah, correct, 200. Enter, and then generate. Something wrong with my edit. There should be a false command. Okay, let me generate again. Okay, let me edit. Okay, Yeah, so you should see an arrow like this on the screen. Yeah. I think just now I didn't select the face on the top here. So you need to select this face and then click apply. Okay, then click generate. So it will generate an extrude part like this. Do you get what I get here?
Yes, sir.
Okay, now we do the same for another part here. So what we do is just go to extrude again. Yeah. And then do another side. Yeah. So face, extrude, apply. Okay. Generate. Okay, you get the two length coming out. And then the next one is we're going to generate a small pipe, this one, inside the body. So what we do, we'll do the same. Now we're going to create a cylinder rather than using the donut. So we're going to go to create and go to primitive again, go to cylinder. And you see there's a gray object in the window here. So you need to do some setting about the cylinder before you click the generate button. So let me see. Cylinder one, we don't change anything, the name. Base plane, XY plane, which is correct. Operation, we don't need to add material at this moment. Coordinate, yes, we need to change the coordinate. Yeah. So coordinate 137.5. Yeah, key in 137.5 at x coordinate. Negative 225 for y coordinate. You're seeing the object is moving around. We want to get the cylinder in the middle of the pipe. Z coordinate 0. Go to axis, x-axis 0. Y-axis, you need to change a little bit. Y-axis is 125. Z-axis is 0. And again, we need to change the radius. So if you look at the drawing, the radius here is 25 diameter. The software asks for radius, so divide by half, we get 12.5. So key in 12.5. Enter. So once the parameter looks all right, and if you view around, the draft is in the middle of the object. It looks fine, then you go ahead and click generate. So we have created your first 3D model. Now we want to simulate, we want to see the pressure in the middle. So we are creating a symmetry plane later on to generate our results. So we're going to generate, hold on, there's one symmetry steps. Okay, you go to tools. You want to create a symmetry plane, so go to tools and then click symmetry, tools symmetry. Then in the tree here, you'll see symmetry 1 come out. Yeah. So and then go to detail here. Go to detail here, you will see what parameter that you want to apply. So just click apply. Oh, sorry, before you click apply, you need to, because we are using in the general axis here, you will see that our y is going up, x going up, and z going up. We're going to cut this object using xy plane. We're going to cut this plane, this object using xy plane. So you go and click xy plane, click xy plane, and then go to the detail there, click apply. And then click generate. So you see your object is cut to half now. Yeah. So in your tree window here, you should see torus, extrude 1, extrude 2, cylinder 1, symmetry 1, and there's a body named solid here. Okay, stop me if you're not able to follow. We're going to specify the body here to become solid. So what we do is I click the solid here. Left click, the body will become yellow color or light green color. We want to change, because we're going to simulate float, and all the float will go through all this body. So not to confuse us that we are simulating solid, we're going to change this name to fluid. FLOLD, key in the fluid there. And then go to the setting here. Remember to change this one. The computer, although you change the name, but the computer in the setting now is the software is seeing this one as a solid. You need to left click and then drop down, go to select fluid, so that in the simulation, the software itself know that the body represent fluid rather than solid. Okay, after you done all this, yep, everything seems fine. Go and click generate. So you're seeing the proper setting for your model now. You have a few parts here, and the body here represent fluid. Yeah. Okay. After you done everything, you happy with your model, you can close the modeler now. Just click the X here. And then you go to your ANSYS software. You will see your geometry now have a tick, which is ready to proceed to meshing procedure. And there's a file below here. So if you want to view what file they originated, you go to view. And yeah, file is tick. So let me see. Yep. So in my software here, what we do is that you already generated a project file, WBPJ project file. There's a database file. There's a geometry file that you just created, added, and there's a Workbench design point file also here. So four file already created so far. Okay, so of course these steps you can skip when you have a 3D model that you can design better with other CAD software. I myself prefer to use other CAD software and then import into this Workbench. Okay, remember to save in the acceptable file format. You can save in STL file, .stl, or .igs file. Okay, both same. Now we're going to into mesh component. So what you do is that you go to mesh here, and then you just right click, and then you can see the property come up here. So later on we will make changes here. So far we do not need to change anything. So we go to edit. The mesh profiler will come up, will load, and wait for a while. The meshing, starting meshing at the bottom here, the status is starting meshing, meaning the computer is open up a mesh modeler. So it's another platform. So wait for a while. Your 3D model going to come in here. So you're going to see everything. There's no red. There's no red button, or there's no red color come out, means everything in good condition, and you should see a model inside your window here, right? So the first thing is that we want to name the location of our input, output, outlet, and ANSYS. So the first thing is that we're going to create a name selection. So the first thing is we're going to name the first one as our velocity inlet, which is here, our velocity inlet, which is bottom of the object. So you just rotate the object, and this is the location we want. So yeah, make sure you're selecting the face selection here. So left click and then right click, left click, right click, and then go to here, create name selection. So that later on you don't need to go to the exact location, you just highlight from the project tree here. So we're going to name this one as velocity inlet large. In ANSYS, try to avoid space in the name here. Yeah, try to avoid use space bar or space between the wording here. Yeah, and then just click apply selected geometry. Click OK. So on the name selection on the project bar here, if you expand, you'll get that there's one name selection here. We'll continue to name other. So for example, the bottom one, this one, the bottom one, we will name, left click, right click, again repeat, create name selection, and name this one as small inlet because it's small. Small velocity, small velocity dash inlet, because we have two inlet, one big, one small, and click OK. So in your project tree here, you'll see another name selection added, which is called velocity inlet small. Then there's one outlet at the top here. Left click, right click, go create name selection. This is our pressure outlet. So pressure outlet. Click OK. And then there's one more symmetry plane that we will project the results later on. So we will also select this symmetry plane. Left click, right click, and then go to create name selection. Name as symmetry. Then click OK. So in your project tree here, you have 4 locations. So later on, your result will appear in a symmetry plane here. Okay. Right. So this is our object. Once we have named the selection, we're going to name our body of this one to tell the meshing, tell that we are meshing a fluid body. So just now we only select faces. Now we're going to select a body. So what you need to do is you go to the top here, select body, then go and select in the window there, go and select the body. So you go and highlight green color. Again, we need to name this body again. So right click, create name section. This one as our, let me see, any name. Okay, I will name this one as fluid. Yeah, fluid. Then click OK. All right, so in our name section there, we have a few faces and our body as fluid. The next one, we're going, after we have all the name section, we're going to do meshing parameter. So go ahead and left click mesh, and then the window will come out here. So in the mesh property here, you know that the solver automatic detect that you are using fluent. You need to check most of the time when you simulate, sometimes your previous user or previous customer, he just pass you a preloaded model, so you need to be careful on the setting here. Then what you need to do is we need to change something. Go to quality here. We need to change the quality. Smoothing, by default, my one is medium. We change to high. Smoothing, what is the effect when we change the smoothing effect is that it will increase the accuracy of your result, because we know that the data or the result is connecting line by line or curvature or a straight line or a sharp edge. So if you activating the smoothing means the flow of your data will be more smooth and the error will reduce. So another one is on the let me see, sizing. Sizing seems all right. Fonts. Okay. The next thing we're going to improve a little bit on our meshing. We want to improve a little bit on our mesh sizing. So what we do, we go to mesh here. On the top window here, you see a mesh, not mesh. Go to mesh, right click. Okay, mesh, right click, insert, click sizing. We need to further improve our sizing. All right, and then in the geometry here, you click your selection here, you click your geometry, then click apply. Means it detect one body to do further sizing. And you want to define our sizing. So my one by default is 29.197 mm. It means that when we do meshing, you'll see a small triangular or tetrahedral. This one is depends on the element size. So this one 29.29 mm. If you look at the diagram here, your dimension is 200 mm, and you are using if you do like 30 mm here, you are breaking 100 mm from this point to this point by using 30 mm. So you're going to see 3 cube here. Are you able to understand what we are trying to do now? Okay, I open the PowerPoint slide and I use pen to draw. So if your size element by default in the computer, let's say you have, yeah. Again, I cannot get your seat. Can you repeat what you're saying?
Okay.
Yeah, you understand, right? So yeah, yeah. So just now we are talking about this meshing size.
Continue, sir. Continue, sir.
Yeah. So just now I'm talking about this the element size here. So element size here is about 30 mm, so 29 point something. What does it mean? It means that we're going to break the meshing. Let's say I take this as a portion. So here to here is 100 mm. If my size is 30 mm, I'm going to see roughly 3 elements for this one. So if you compare the ratio of 30 to 100 is very large. So the simulation, the result will be very cost, means it will be accuracy will be low. Accuracy will be low. So these are some of the understanding on the setting here. So here we change 6 mm. Yeah. Okay, maybe before we do testing lah. So let's say we do 30, enter. Then we generate the meshing. Then you see what happened. Huh? You update, you click the update. You will see, okay, the meshing is too big here, so it's not able to generate anything. So change to 6. You go to the bottom there, change to 6, enter, means 6 mm, and then go update. Okay, then click somewhere in the, I think, okay. Now you're seeing the mesh quality is better. I repeat the previous one. I go and change to 30, enter, and then I update. And then I select the mesh. You see the quality that we have is too coarse here. This is too coarse, and if you want to run simulation, this is not a good meshing criteria. All right, so what you need to do is go to body meshing again, change this one to 6, enter, and update. Okay, then click mesh. So this is a good one. If you compare the previous one, this is a good one. Of course, you want to more detail, you can reduce further. Then you get a better estimation. So we are done with the mesh so far. Okay. We have done with the mesh. There's no error, there's no nothing. There's all tick here. Close the mesh. So on your workbench here, your mesh is done. And in your file component here, you will see the mesh already done. The mesh database file is added to your project file. So just now you don't have the .mshdb file. Now you have, yeah. So we're going to, yes.
No, sir.
Yeah.
Wait, sir. I think, okay, wait.
You already
My
meshed already,
screen
right?
is a bit, okay, now continue, sir.
You
First,
already meshed already, right?
this, actually, I'm already left out, sir. So, never mind, sir. You continue first. Later, I see the recording part.
Now where are you? You're still not doing the meshing or what?
I haven't continued with the meshing because just now the line cutting. So, never mind, sir. Later, I will see the
Okay,
recording part.
I can redo the meshing actually. No problem. Yeah. So where are you now? You are geometry already done.
Still geometry only the half first part only I've done, sir. The continue part I haven't done. So it's like, yeah.
Oh, okay.
Let me show you.
Okay, never mind. Maybe I will just continue, and then in later
I will
session,
see
then
the
I will
recording
come
part.
back. I'll do the recording first, and then I come back to help you. Is that all right? At least you
Okay,
know
sir.
the flow first.
Okay.
Yeah. Okay, now the next one, once we do the meshing, we do the setup. Okay, so what you do is that you go to click setup, and you'll see the property that you can do. Normally, I will just go and right click and wait for the edit. So click edit. Okay, so this is the page that is important when you try to use the Fluent solver. So we will use double precision. There's a specific topic on double precision setting, so I'm going to skip at this moment. Double precision means give you a better calculation and reduce the, it depends on computer. Some computer give you less calculation time. And processing option here, you have two. One is serial, one is parallel. Yeah. So serial means you will solve one equation. After done one equation, and then it will continue. In this case, I will go parallel. So parallel means I solve simultaneous equation in one go. So I have, in this case, I choose 4, means I solve four equation in one go. All right. And then, yeah, make sure you tick the displays mesh after reading, and Workbench color scheme also activated. You can expand the more option here. General option, parallel setting here is by default. Environment, you can see where the file is going. Yeah, and after that, click OK. Then you wait for the Fluent solver open up. Okay, you wait for the Fluent solver. So this is the environment of the solver. How you know that the solver is ready for your input? You glance through, there's no red color, there's no warning sign, and you see a model inside there. And then here on the console here, you see everything is all right. There's no error message here, which is good. Now, in Fluent, we go by, you can go by tree or you can go by toolbar here, both same. Again, before you start anything, make sure the unit is matching what you do. So in the setup domain here, go and click unit and check the length, because we are focusing on length. So click length and you see the program, or my program here, you see is automatic by default is in meter. I want you to choose mm. Yeah, be careful on this one, because if you do not do properly, later your result will not tally. Yeah, then click close. After you click this one, click close, you auto save. Yeah, so in your notes over there, you just write, remember, once you open the Fluent, go to unit and do setting, go to unit, go and choose length and change to mm. Yeah, just a short note so that later you can follow up. Then after that, optional, normally I will just go and click the check the domain whether it's correct or not. So I just click check, and then you see something happen on the console here. Click check. So checking done, everything's look okay. Give you the maximum, minimum. The mesh is done. There's no error here, which is good. Then you check for quality. Click the quality. It will check for the quality where your mesh quality here, aspect ratio is 1.3. E plus 0.1 means 10 power 1. So it means it's 13 aspect ratio. So if you go simulation, if you want to be better, keep this number low. Keep this number low. Okay. What else? See anything that I miss out. Okay, once we have done, then we go for after domain done, then go to setup physics. So setup physics here actually is the same on the tree here, where you will see the same as above. So you see physics time steady, pressure based, solver absolute. You will see the same on the tree here if you click the general here, model. Yeah. Okay, here we need to set we need to activate our energy. So what you do is that you go to the tree model here and go to model here means you what equation you want to use. All right. So we have one until here. We have multi-phase, energy, viscous, and so on. So all is off by default. We want to on the energy equation. So you click this one, double click, and click energy equation. Click OK. So the energy equation is on now, means you are using energy equation to solve. And our model here, because we know that we are going to run turbulent flow inside the pipe. So we are not going to run laminar flow. What you do is go here, double click, and the viscous model come out. So you have a loss of model here. So later on in class, I will teach you on detail on the formula like here. So you have implicit flow, K epsilon, K omega, and so on. So each one give you to solve different problems. So for turbulent condition, favorite one is K omega model. Constant, model constant, by default, we don't change anything at this moment unless you go further advanced level. And K omega model, we're going to use SST model. SST model. So there's a chapter for SST under turbulent model. Okay. And other, you just keep as default so far. Okay, once you're done, this one click OK. So make sure the model you choose is correct. So you're activating energy equation and also turbulence model using SST K omega viscous. Other is off. Huh? So how you know it's off? You just extend the window here, on off. Okay. Now next is the material. So expand the material here. So you double click the material here, or you can go to the top here. There's a material button here. So inside here, there's no water. We need to simulate water. So there's no water in the material column here. You can click edit material here, or you can go bottom here, create or edit. So I like to use the 3 section here. I go create, edit. So what you do, you create a float of water, right? So you don't need to key in all the value by yourself. You can go to the library of the ANSYS. So once you open up the edit material, you go to Fluent database, click Fluent database. So there's a database you can choose. Yeah, there's lots of Fluent medium that you can use. Go to the last one, last 3, water liquid. Click water liquid and check the properties whether correct or not. Normally it's correct lah. So you just need to check. Why you need to check? Because sometimes if you use a shared computer, someone will go and change the value here. So you need to be careful when you share computer. Click copy. You want to copy this value into here. Click copy. You see a water come out. Water liquid. Close. And then close. So here we have the material. We have float. We have water and air, and also solid aluminum here. So in our simulation, we can run all this material. Okay, once we set the material, we go to the next steps, is our cell zone condition. Okay, cell zone condition. So if you double click cell zone condition, you see a float there. Yeah. So what you do is you just double click the float. So you do some parameter setting on the float. So you see, if you do not do anything, although the name is float, but the material name is air. So if you do not careful, on outside, it seems like a float, but you're simulating air. So here you need to change to water. Material, change to water. And the rest, so far, we don't do any complex motion. So, and anything, you just click blank, then click OK. So in the window here, you see the float type change to float already. Yeah? Okay, so this is some important parameter for the fluid. We have done on the cell condition already. So done for the shell. Now we move to the boundary condition. So if you expand boundary condition, you'll see that we have a few boundary condition here. You double click boundary condition. We want to input our boundary condition accordingly. This is where the software try to solve your boundary condition. So the first one, we look at velocity large, which is at the back here. Yeah. So you click velocity large and then go to edit. You want to input some value because by default there's no value there. Yeah. So by default you see there's a velocity coming from the below here. The magnitude is 0.4 meter per second. So what you want to do is that you go to here, tell the computer that the velocity at the inlet large here, the magnitude. Okay, so this one you need to be careful. This one you need to make sure that it's normal to boundary. Yeah. Absolute, and velocity here we change to 0.4. Enter. Make sure the unit is correct, is in meter per second, and there's no supersonic gauge. And be careful on the specification method. We're going to use intensity and hydraulic diameter. Okay, hydraulic diameter means when you simulate, your flow is going to follow the setting that you do. So in here, by default, is 1000 diameter. If you look at your diagram, here you only have 100 diameter, right? So if you're not careful, you do not do the proper setting, your float will going to come in 1000 meter from the left. So you're going to simulate the wrong parameter. So we only want to focus on 100 diameter here. So what you do, you change this one to 100, enter. Okay, so seems everything okay. Then you click. Okay, then how you find the hydraulic diameter? There's a formula. There's a formula. In my slide here, I input for you. There's a formula. Oh yeah, this is the formula that I'm talking about. The hydraulic diameter that you set is given by this formula. DH equal to 4A divided by PW. PW is a weathered parameter. So this formula you can find in the fluid mechanics chapter also. Yeah. So there's an equation for it to calculate this one. Then click OK. Once we're done for the velocity inlet, okay, let me check. So be careful on the thermal. Just now we set this one and then go to thermal. Temperature here, the temperature for the inlet is 20 degrees C. 20 degrees C is about you plus 273.15. You get 293.15. Yeah. Then click OK. Means you already set. What do you set now? What do you do setting now is you set the parameter for boundary condition for velocity at this section, magnitude 0.4, hydraulic diameter 100 meter, 100 mm, thermal temperature here is 29.15. Then click OK. Then the next one you also need to do for small inlet here. If you look at the diagram, small inlet here is 1.2 meter per second, temperature 40 degrees C, intensity is 5%. So you go to boundary condition here, double click the inlet small. Magnitude here is 1.2. Then we don't have a supersonic. We intensity 5. This one given in the diagram. Yeah, intensity 5. I 5%. Okay, here we need to change. This one we are not using viscosity ratio. We are using hydraulic diameter. So again, if you do not do anything, it will calculate in 1000 meter per mm. You only have 25 mm there. How we know 25? We check the drawing. The diameter is 25. So just key in 25. Yeah. Click OK. Oh, sorry. I need to check the temperature. So temperature here is 300, which is wrong. If you convert 40 degrees C to Kelvin, it will be 313.15. Enter. Click OK. Then after that, we need to set for our pressure outlet, which is here. Go there, double click, pressure outlet. Yeah. So from the diagram, we don't know the parameter, but we let the computer to calculate for us. Yeah. Here, what you need to be careful is on the here. We are not looking at viscosity ratio. We're looking at hydraulic diameter. Again, we need to change but the default value from 1000 to 100. Enter. Okay, check the temperature. Temperature we just set as constant. We don't do it because we have no input there, so we just by default let the computer to calculate for us. Then click OK. Now once you're done with the we'll call the setting, the next step is called solving. We have done with all our setting here already. Means what we do now is we set our velocity input, inlet big and small. With this, we have two inlet here, inlet from the left and from the bottom. We do the setting and then we do the pressure setting here. Yeah. So next one, we go to dynamic match. So dynamic match is nothing you need to do at this moment. Reference value also keep as default. Then you go to solution. Yeah. So if you expand solution, the first one you look at is method. So in this one, you're going to use another solution, another equation. Under pressure velocity coupling equation, we're not going to use simple equation, but we're going to use coupled. Pressure velocity coupling equation in a coupled setting. Partial discretization, this one gradient we're going to change. We're not yeah, I think we least square I think still can. Pressure second order, momentum second order, and turbulent kinetic energy we want to improve a little bit on the accuracy, so we will go until second order. Okay, change to second order. Dissipation rate, I think, yeah, we also go for second order for more accuracy. Check more. Okay, so everything is in accuracy, means your answer is more accurate. And check the pseudo transients. We're going to use pseudo transient procedure for the solution. So all these are important parameters when you talk about your projects later on. All these are the setting that give you the results. You explain why you get a certain results. Yeah. Once you're done with the method, you go to the control, double click the control. So here control, there are setting they can do in here. I will just keep by default 1 and 0.5 means the intensity that relaxation factor that you want to do. So 1 means you have more relax, means your calculation will be more linear. Yeah. Okay. The weightage of that component, for example, 0.75 means 17% relaxation. Yeah. The next one is your report definition. Here, you can input your definition if you want. At this moment, we just skip this step. And on the monitor, so in monitor here, you can control other parameter here. So monitor means you project to you. So we're going to set the residual value. So double click residual. So we're going to print or present our results to the console. We're going to print and also something that we need to set here. 1000 iteration to plot means you will run 1000 times. You'll calculate 1000 times for you, 1000 times to calculate here. let me see. Means you will have x velocity, y velocity here. So all these you can set, and all these are under your monitor. Absolute criterion I set by default. This one depends on the spec on your company specification. What else? Okay. Okay, the next one, there are some function which is not here. I will need to use the toolbar here. It's called I need to find the new report. Yeah, just now we do the residual. I need to give a new definition. So down definition, new. I need to give a new surface report. Go to surface report. And I choose fractured maximum. Click fractured maximum. So I'm going to create one report is called temperature outlet. The report is called temperature. We're going to see temperature outlet now. Temp dash outlet at 0. And the rest is, so I need to change because I'm going to plot a temperature. So field variable, I change to temperature. And here we only have static temperature. And then the surface that we're looking at is our surface outlet. Okay, surface outlet mean that we are depending on surface outlet here. What else? And create on report file. We want to save the report. So click report file, report plot also. And frequency here I changed to 3. Okay, what I mean by 3? It means that you ask the computer to plot the data after 3 calculation. Yeah, you update the plot of this surface report and write the data to the file every 3 iteration. Right, this is the frequency 3 means. And then, yeah, we don't need to print to console because we don't want to see it on our monitor. Since everything is okay, then click OK. So when you click OK on the 3 bar here, you will see in your report plot here, there's a temperature outlet here. Yeah, temperature outlet there. Then we need to create another one is the pressure one. Yeah, pressure. So you can check the file here. So another one is called there's one more file that missing. Yeah, okay. So I think everything makes sense now, because we need to make sure that we have a report file under here and also report plot file here, because we need to see the file. Everything seems fine. The next thing is we just go and run our initialization. So you can go to the top here, or I still prefer to use a tree on the left here. So I go and double click the initialization. You need to tell the computer to run some assumption in the calculation. You have two assumptions. One is standard, one is hybrid. We're going to use hybrid and click initialization. This step, most user they forget to initialize this. They forget to click this one. So once you click this one, you see something happen in the console. I click. You see something happen in the console, and hybrid initialization is done. And you see this one warning, convergence tolerance of this one do not meet, but however, we still continue. Still continue. Then after that, we will, if anything, nothing to set, we will run the calculate. Okay, before we run calculation, double click run calculation. Here, also very important, where you will set how many iteration you want. Yeah. So here number iteration means 0 means no calculation done. If you input 1 means 1 calculation, then it stop. We were going to run 250 times. Yeah, we're going to run 250 iteration. Means you run the formula 250 iteration throughout the process, then the program will stop for us. So once time factor is 1, means used by second, and nothing else. Everything looks fine. Click calculate. So it is time where the computer will start running, and you see something happening on the console here. Iteration number will continue until 250 that we set. Okay, and the parameter is coming out. So this one, where you can extract this one, you can extract all these data file in the log file. All right, and on the window here, you will see there's a 2 window that you can click. One is a scale residual, one is a temperature outlet plot, which means that it monitor the temperature of the solution. So what you want to see is that the temperature might go up or go down, and then it will reach a converge stage or convergence where you will see a flat line, which means that the solution meet agreement in most of the point. So you see our calculation complete, then click OK. And what you need to check is on the graph. So the first thing you look at the graph is that the convergence. This line is important. So when you show your projects or your data to the examiner, this is the very important graph that you show. So if your graph go down, or if your temperature parameter that you check do not meet this line, means your calculation is wrong. Then you check the residual. The residual will drop until the minimum, until your iteration. The number of iteration here, it only show up to a certain thing. So why it show until 100 something? Because from the console here, you see, until in the console here, the solution meet convergence criteria at a step of 146 steps. Even though earlier we set 250 iteration, but if the software found that the data converge or meet the minimum criteria of your convergence, it will auto stop for you. So in this case, our results meet or solve at the stage of 146. Yeah, and here you can see your temperature become constant. So this is an important explanation to your examiner when they ask question. How you know your data is converged? So you show this data, show this file, and this presentation to your examiner to show that your data is converged. Yeah, and calculation complete. So at this point, we already done with our file. So we need to further analyze our results. Yeah. So what you do is that this one, once you're done, you can close this one and we can go to our Fluent over there. So you close your Fluent solver. You should want to click yes, click OK. Wait for the computer to back up the log file. And now in your Workbench, you see the solution is ticked. Now we're going to analyze the results. Yeah. So how you see the results? Right click, edit. You open up another platform called Post Processor. So here you see CFD post means that it's a post processing, and you should see your model on the right hand side, and all the parameter here you see here. However, you do not see the temperature gradient and all this. So you need to tell the post CFD post to present it to you. So we need to do it now. So how do you present? You go to results. You can straight away use all this. So I'm going to use an icon here. So I'm going to use contour. So I click contour. Insert contour one, click OK. So contour means I'm going to plot my data. So I'm going to extract all my data. So I go to the contour here. I choose contour that I want. And in this case, I'm going to show two contour. So first contour is my velocity. So domain here. Hold on. Something seems not right. Contour. Not this one. Insert contour. Okay. Okay, look a bit weird here. Contour. Let me choose fluid. I choose location symmetry. So it means I project all my calculation on the symmetry plane just now. Variable, I'm going to choose velocity. Maybe this one. Let's choose velocity. Range global. Apply. Okay. So this is the results for contour 1. If you project, so you will see how you read these results. Velocity is plotted from minimum to maximum. red color is the maximum. So on the graph here, you will see that it meet with what we learned, meaning that at the surface of the pipe, there's no velocity because of the viscous effect. And also the maximum will go here because we have a small nozzle. We agree with experiment and observation. Then the next one, we're going to insert another one. Going to look at the temperature contour. So the presentation is a bit weird, but anyway, we're going to look at float again. We deselect the contour 1 here because later the result will overlap, so we don't want to see the contour. We create a contour number 2. So float, we're going to look at temperature now. So symmetry, variable, we look at temperature, range we put as global, label, everything looks fine, click apply. So here we have a temperature contour. So you will see that the temperature is in Kelvin. So agree means that it looks reasonable because we come in with the cold air, 20 degree from the left, 40 degree from the bottom. There's a mixture of temperature with make sense. With the slow velocity, you see on the region here is cold, and there's a mixture of temperature on the right hand side, and there's a hot water below. I mean, not hot, but 40 degree over here, which agree to this one. So once we agree, so you can switch on and off by going to the tree here to compare the two, okay, to get the results. Okay, this is how you get the results, and you close the Fluent. And here you go. You have everything you need to know about the results, and click Save. Okay, I think we stop the recording here.